So let's say, for example, we have log Okay, so let's say we have these equations here. We can label them. Can call this one equation 1, and I can call this one equation 2. So if you look closely, you'd realize that equation 2 is simpler or easier to work with. And based on that, I can tell that log y would be easier to make the subject because we can easily substitute it here in equation 1. So from equation 2, I'm going to have a log y being equal to log 6 minus log x. So I can now substitute that into equation 1. So we have log x plus 2 plus log 6 minus log x being equal to log 12. So now, if you realize here, we're adding, so that means we're basically multiplying logs. So that'll be log x plus 2 times 6. So I can put the 6 at the front. And then this portion would be dividing because it's subtract. So divided by x, and all of that is equal to log 12. So because both sides are logged, we can ignore the logs. So that's 6x plus 2 over x being equal to 12. So from here, I can expand and cross multiply. So we have 6x plus 12 being equal to 12x. So now I group my like terms. So 12 would be equal to 12x minus 6x. So 12 would be equal to 6x, and I divide both sides by 6. So that means x would be equal to 2. So now that we have our value for x, remember we're doing simultaneous equations. So that means we need to solve for y. So remember from equation 3, which was log y is equal to log 6 minus log x. So log y is equal to, because we're subtracting, that means we're dividing based on the laws of logarithm. So we have a log 6 over x. And remember, x is equal to 2. So we have a log 6 over 2. So because both sides are logged, we can ignore the log. So we have y is equal to 6 over 2. That means y is equal to 3. Okay, so let's say we have this question here. So again, this is my equation 1. This is my equation 2. So if I look here, I'd realize that log y would be easier to make the substitution. So that means in equation 2, I'm making log y the subject again. So we have log y being equal to log 2 minus log x. So that's log x plus 1 plus 2 times log 2 minus log x equal to log 8. So that's log x plus 1. Now from the law of logarithm, once you have a power to the front, because you're going to be multiplying both all of these terms by 2 on the outside, so that would be plus log 2 squared based on the law of logarithm minus log x squared being equal to log 8. So that's log x plus 1 plus log 2 squared, that's 4, minus log x squared is equal to log 8. So again, because this is addition, we're going to be multiplying, then we're dividing this portion. So that's log x plus 1 times 4, so I can put a 4 at the front, divided by x squared, that's equal to log 8. So because both sides have log, we can ignore the log. So that's 4x plus 1 over x squared is equal to 8. So I can expand the numerator and I can cross multiply. So that's 4x plus 4 being equal to 8x squared. So if you look here, this is a quadratic. So we have 8x squared minus 4x minus 4 being equal to 0. So because all three numbers are divisible by 4, I can do that. So we'd have 2x squared minus x minus 1 being equal to 0. So now we'll do the AC method, solving the quadratic. So it's 2 times that. So we have 2x squared minus 2x plus x minus 1 being equal to 0. So that's 2x, x minus 1 plus 1, x minus 1, that's 0. So that's 2x plus 1 times x minus 1 being equal to 0. So we have 2x plus 1 equals 0, and we have x minus 1 equals 0. So here x will be equal to minus a half, and x will be equal to 1. So if you try and substitute this into the equation, you realize that you cannot find the log of a negative number. So that would be undefined. So that means x is equal to 1. So since x is equal to 1, we need to solve for y using log y is equal to log 2 minus log x. So again, because we're subtracting, that means division. So we have a log y being equal to log 2 over x. So because both sides are being logged, we can ignore the logs. So that's y equal 2 over x. And we know that x is equal to 1, so that's 2 over 1. So y is equal to 1. So that is it for solving simultaneous equations that involve logs. Thank you guys for staying tuned, and I'll see you guys next time on the Dark Tube.